My name is Caleb Webster Alt. This is for FTE-217 week 3 assignment. So for this video, we are going to rely upon our understanding from the material this week, choose 3 components within the AR platform, and answer the following. So for the 3 components / parts that I've chosen to speak of, I have chosen the extractor claw, the fire control group, and the receiver extension tube. So to begin, it says for number 1, what are the critical dimensions associated within these components? So, for the extractor claw, I did find a PDF on a very old forum. I don't remember what it's called. I just have the PDF pulled up now. It's a PDF on a drawing of a bolt assembly diagram. And on page 7 out of 18 is a clear depiction of the extractor claw removed from the actual bolt assembly, and it gives you all of the dimensions. So the dimensions that I took of mine, I have an extractor claw in this little bag here. I measured it, and the width was 0.2450 thousandths of an inch, or whatever, or 100 thousandths of an inch. For length, it was 1.235. So, which does, when you look at this PDF and you zoom in to the measurements that they had for theirs, those are matching up. So these are mil-spec measurements. The width is on average, 0.250 thousandths of an inch, and the length is on average 1.2 thousandths of an inch. So that's correct there. I could show the PDF, not very well though. Hold on, I gotta lift my computer up and out of here. Just to give you guys, I guess, at least a view of it. But there is a clear, diagram with all the measurements in place of an extractor claw. The face of it, the side of it, everything. Multiple views, multiple angles, with multiple measurements all over. So this was a pretty cool find. Something I've noticed with critical dimensions with mil-spec parts is that it's not like public information, at least not if you don't purchase it. If you don't pay for a PDF file to tell you the specific measurements on these parts, you're going to have to measure them yourself. So that's for the extractor claw. Onto the fire control group. So I wasn't doing much thinking when it came to the fire control group, because I didn't quite realize, oh, I'd probably have to remove everything and then measure it. So for the fire control group, I'm just going to measure the mil-spec measurements for the pocket. So that's what we're going to talk about, is the fire control group pocket. So what I did is I just measured width, length, and depth. And what that came out to be, for the width, it was 0.6905 thousandths of an inch. And then for the length, we got 2.510 thousandths of an inch in length. And then for depth, it was just 1.2. So I couldn't find anything. Keep in mind, I did try to find sources for information on mil-spec dimensions for things, but nothing comes up on Google, nothing comes up anywhere. That's just not a thing, not really. Even on Numeric, you can go on their schematics and everything. They don't have diagrams with measurements. So I looked in many places that I at least knew, and I couldn't find any information as to any specs on a fire control group. So I would assume that is because it is made up of multiple components, and it's not going to be very easy to relay that message to the public, I guess, and show a diagram with all the measurements of all the parts. So that's why I decided to just measure the fire control group pocket. So now let's just move on to the receiver extension tube. Is fairly simple. All you're measuring here, at least all I measured, was width, because width is what's really important, because that allows mil-spec stocks to be installed. and the width is 1.14 thousandths of an inch. So in diameter, that is this. So I just measured the width of that, and that's what it is. So those are the simple dimensions for things. I tried to look for sources, as I said, but it's much harder than you think. So let's go into number 2. What potential malfunctions may occur if damage or improper modifications were made to the components? Explain the specifics behind these malfunctions. So with the extractor claw, let's begin there. And I'll actually pull my extractor claw out. On an extractor claw, I don't have very good lighting in here, but this is the front portion. This portion is what pulls the casing out of the chamber. If that claw, if that indentation, you can't really see it. I don't have a very good camera, but this is technically a claw, and it's going to grab the casing of that cartridge. Over time and over excessive use and fire and pressure, these sometimes shear. They'll break, and or they'll just stop functioning from just wear. So that's the damage that you want to be looking for, is right here on that tooth. I call it a tooth. It's just like an edge. It's a claw. If there's any damage on that, that's what you want to pay attention to. You're going to be experiencing failure to extract. What you're going to have a problem with is that the extractor claw is going to slip over the casing instead of really grabbing it and ripping it out of the chamber. It'll just slip, and it'll leave that fired casing in the bore, and that's just no good. So for the fire control group, things that you can experience if the fire control group is worn out, specifically things like springs wear out. They are properly calibrated to function properly, and in specific, if your hammer spring is just you shoot it a lot, and it's getting worn, and you start to experience light strikes, failure to fires, that's what that's going to do. Is so just pay attention to the life of your springs, and when you do take your fire control group apart and you clean it and maintenance it and you inspect it thoroughly, you're gonna be looking at the sear surfaces and everywhere where hooks meet a ledge, and so just look for wear patterns. And like I said already, you're gonna experience things like failures to fire if you have problems with your fire control group, because it is the heart of the gun. So damaged fire control group, gun don't go bang. And then receiver extension tube. So with this, not many parts or failures would happen, I guess, per se, I guess. I mean, there's no really real way these could break. The only thing I can think of is if you don't torque this down properly and it makes its way loose and it falls off, that could cause a problem. We could sit here and argue what failure it would cause, but it would probably cause a multitude of things if this were to break back here. I don't exactly really know, but for things to look for, pay attention to your castle nut and how the locking plate was staked to it. Pay attention to certain things like that, because if it wasn't properly staked, if it wasn't properly torqued, it's going to come loose. So, for number 3, what damage is likely, if any, on these components and why? So I kind of already went over that, getting ahead of myself, I guess. But, like I said, damage dealt to these, for the castle nut at least, for my instance, when I installed this, my, the armorer's wrench that was supplied, the actual tooth itself sheared. It snapped right off, and it did scrape up my castle nut a little bit, sadly. So that's when I come back to the importance of buying or investing in good tools. You need quality tools to do this work, or else you're going to damage parts. For example, today I just tried to remove my ejector, and with a roll pin punch, all the appropriate tools, all necessary stuff, I had it. I did it all appropriately. And the cheap 1/16 inch roll pin punch seized, and it is now lodged and stuck in here. I got the roll pin out. Everything's great. Besides that, the roll pin punch snapped and seized in this hole. What does that tell me? That tells me that that cheap little punch probably wasn't exactly 1/16 of an inch. A punch should be able to slide in and out of a hole, no problem. So, don't buy cheap tools. For number 4, what training should a gunsmith undergo to avoid causing damage to these components? So, yeah, great. Training. Manuals. I would, read books, those books are full of a lot of information, and they go into great detail when it comes into things like detail stripping and disassembly and reassembly and stuff like that. So for training, definitely read books. There's lots of videos out there. There's lots of resources to our fingertips, lots of informed people, lots of professional gunsmiths that post videos for people to watch, so you can always learn via, the internet. And just good practice, using proper tools, practice what you've learned, practice, on your own things. You're going to learn from mistakes such as this, I did. I'm going to throw these tools away probably and buy all new tools that are worth my time. And although that is sad and I really don't have the money to do that, I have to do that. So this is what we learned from it. Cheap tools break things. So what additional components interact with those that you selected, and what are their critical dimensions? So let's go back to the extractor claw, I guess. And the extractor claw is directly attached to the bolt. And I guess we can quickly take some measurements of this. So let's turn out dial caliper on. Sorry, I am sick, so if I sound a little funny, that's why. So let's just take a quick measurement of width. I'm getting a measurement of 0.5 thousandths of an inch, roughly. And for length, I'm getting roughly 2.8 thousandths of an inch. So those are, rough dimensions. I'm almost positive that that is mil-spec measurement, within at least 1 to 3 thousandths of an inch in variance. So for the extractor claw, the bolt is the, what would they say, additional component that does interact with this. And so this is what holds that extractor claw in place, and it works in direct conjunction with the ejector and everything. So this whole assembly works together with the ejector claw. Moving on to the fire control group. For the fire control group, when you fire, the hammer contacts the firing pin. And here's a firing pin, so I can show you that. Here's that. And let's just take some quick measurements of this. So width-wise, we are getting a measurement of 0.1 thousandths of an inch. For a length, I'm almost positive, I'm pretty sure you measure from here to the tip. Not from all the way to the end to here. From here to the tip. That's the mil-spec measurement. So just keep that in mind. So we'll fully extend here. And I'm going to have to eyeball it, kind of like you're aiming a gun. You're lining up sights. But I'm just going to bring that to the very tip. And I got a rough estimate of 2.7 thousandths of an inch. So, there you go. This right here plays a direct role in the when the hammer makes contact. When you're firing and the hammer makes contact, it's going to contact the back of this, plunging this forward which then lets the round go bang. What additional components interact with a receiver extension tube? So that would be the buffer spring and buffer. So let me grab something to push this detent down with. Just a little screwdriver should do. And we'll carefully push this down. And this will come on out so I can show you. So here is the direct thing that plays with an extension tube, which also allows your gun to function, which is the buffer and the buffer spring. So the buffer spring you can't really measure, and this is actually press fitted in, so we're just going to measure it as is because we kind of can. So for width, for the buffer spring at least, we are getting an estimate of 0.7 of an inch. For the length, let's just bring it out and down, lined up. We are getting a 3.2 of an inch. So those are all the measurements. That's everything measured. That's everything that works in conjunction with each other. We went over mil-spec dimensions. We went over possible areas of damage. We went over malfunctions that could be caused from that damage, and so on and so forth. So I believe that is it for this assignment. That covers everything, at least at my best ability with the resources that I could find. So yeah, to give the guy credit for the PDF file that was shared, at least I think his name was on here. I remember the first name being Jared, so that's what I remember. But yeah, so some guy named Jared provided me the PDF file on some old forum back in 2015. I don't even know. But that's it, guys. So that's the video, and we're gonna end it here because it's 10 minutes over the requirement. So thank you very much. Have a nice day.